Hi everyone, and thank you for listening to this presentation. My name is Gilbert Bernal, and my project is titled The Establishment of Regis Healthcare Informatics Database. For this project, we're going to go over a few things. First, we're going to start off with the introduction, the database requirements and goals, the tools used, database creation, a code review, analysis done to test the database and code, a conclusion, and possible projects to follow. Just so everyone's aware, I am a data science student with the emphasis of data engineering. Because of that, this project is going to be more data engineering focused. The goal of this project was to design a database for the Regis Health Informatics School. The data that's going to be used by the Health Informatics School is data provided by different healthcare organizations such as WHO, the CDC, NIHS, and SAMHSA. These healthcare organizations typically provide data in different formats. The one that I noticed was the most used was a CSV file. CSV files are comma separated values and are used by many as a simple way of storing data. Because of the fact that they're used a lot, I decided that it would be best to just stick with a CSV file instead of using JSON or XML. So after talking to Dr. Ola about the requirements for the database, I decided that the database should be able to store any individual's healthcare data. And that's because multiple people can use this database and look at data from different organizations and on different topics. Because of that, we had to make sure that it all could be stored and that there must be a way to create a table based on the CSV file itself. This means taking the CSV headers and columns to get the right name and data type for the table. After that, the CSV file would have to have its data uploaded to the unique table created. So overall, the goal of this project was to create a database and code that will be able to pull all CSV files within a single directory, create a new table, and create the headers of the table for the database based on the headers of the CSV file and upload the data to its unique table. So there were three different tools that were used for this project. The first tool that was used was PostgreSQL. Out of all the databases I've used, the one that I think is the most simple to use and straightforward is Postgre. It's not as picky as other ones such as Oracle, and it's open source. Out of all the databases I looked at, I decided to stick with a relational database because of the fact that it uses the simple standard SQL, unlike databases such as Mongo, where you might have to have a little bit of different coding and thought process when working with the data in that system. So I thought that was important because I wanted to make sure that anyone that wanted to use this tool or database can simply go in, get their data and table created, and then start working on building queries for it. Another reason why I thought Postgre was a good choice was because that it works with various data types such as CSV, JSON, and XML. It also works with different coding languages such as Python and Java. But most importantly, it works well when trying to upload data to a specific table with a command called copy. Copy simply allows the user to type the copy command, pick the file that you want and the table where you want to go and its format. Because of that, I thought that this was the best database and tool to use for this project. Python is an open source high level programming language. I thought that Python would be a good choice for this project because of the fact that first, it works well with PostgreSQL, has various libraries to manipulate data and files, and the fact that it has a package called PyCorp2. When looking up packages to use with PostgreSQL and Python, PyCorp2 was the one mentioned as the best one when working with Postgres, and it also had the ability to connect and use the copy command that we need. The next tool that was used was Tableau. Tableau is a powerful analytical tool and is something I use on a regular basis at work. The best part, in my opinion, about Tableau is the fact that it has the capability of connecting directly to databases and pulling the table. This makes it easy for quick connections, speed, reporting live data, in my opinion, is the strongest part about Tableau. It also allows you to run SQL in the program itself based on the database that's connected to. So since it's able to connect directly and use SQL, I decided that Tableau would be the best tool to use for the analysis to test the database and codes. So the first step that had to be done for this project was to simply create the database. The database chosen, as mentioned earlier, was Postgre. When creating the database based on Postgre, it's really simple, straightforward, and I ran into almost no issues when doing this. The first step that had to be done was simply downloading the executable file needed and then following the steps in order to make sure that the database connected. After that, I simply tested the connection and made sure that it simply connected and there was no problems. After that, 3 codes were created in order to create our table and import into our unique table created based off the CSV file. The first file that was created for this code was the info.py. The info.py simply just stores our Postgre credentials that are admin. And the reason why you'd want to store an admin user for this kind of code is to make sure that the code was able to upload and create tables with no issues, regardless of what schema is being used. The next code is the import function.py. This code right here is pretty much the powerhouse. It does most of the work. It simply will go and get the CSV file provided to it and create the table based off its header and data in each column. The last code used for this project is the import csv.py. The import csv.py is the one where we will obtain all of our CSV files and use the import function.py file that has our functions needed to create the table and upload the data and make sure that we get that CSV file in there and move it to another directory to make sure that no other table is created more than once. So as you can see, the info.py looks and just makes sure that the user's credentials are in there and the connection information for Postgres is used. The next code is the import function.py. As mentioned earlier, this is kind of the powerhouse of the 3 codes. It does a majority of the work. In this code, we first look at the headers and the information provided within each column. This code will then decide if it is a varchar, a float, integer, or simply just a character. That is needed to make sure that the table runs correctly once the information is stored and uploaded to it. If not, then we would get errors when trying to upload the data. After this is done, a create table statement is created in order to make sure that we're able to run that statement in Postgre SQL command using Psychord2, which we can see happens right here. Also, what you can see right here is the fact that we're using our info.py connection variables in order to simply connect, not have to hard code anything. Right here is where our statement is executed. That statement again is our create table statement and we'll create our table. After that, the variables provided in our next code we're going to review, the import csv.py, uses the variables for the name of the CSV file and the path to import the data to its unique table created in the previous statement above. The import CSV py file simply goes and gets our 2 different paths. Our path is our main path where we will have all our CSV files stored. The archive path simply has the files that were already created and uploaded to a table. This is done to make sure that we do not do anything twice. After that, the function then goes and gets every single file within our directory. This is done by creating a function above right here. Once the function runs, it goes and gets each file in a loop, and then we label it into a variable called CSV file. We name it, by just taking off the .csv and leaving it blank. So we have the strict name that's going to be used to create the table name, the full path, and the archive path. After that, we run our run test, which is done in our import function, and shuttle.move simply moves the files from the first path into the archive path. The analysis done for this project was simply looking to see if there was a correlation between West Nile virus cases and confirmed cases in Los Angeles, California, and rainfall. The West Nile virus, so everyone aware, is a common mosquito-borne illness that occurs in the United States. Previous studies have actually shown that the rainfall affects the Culex mosquito population, which is the mosquito that has the West Nile virus. California has also seen an increased number of West Nile virus cases, and because of that, I decided to look at the correlation between rainfall in Los Angeles, California, and confirmed cases in the West Nile virus. The first step was to collect data from variable sources, or credible sources, I should say. So when looking at that, I wanted to make sure that we got data from a credible source for the West Nile virus and rainfall. The first data that was collected was West Nile virus cases from healthdata.gov. After that, rainfall data was collected from Los Angeles Almanac. Before running any of the codes, we have to make sure that it is clean and ready to go. And by clean, I mean making sure that the headers have no spaces and there are no blanks randomly sitting around in our CSV file. The reason why there cannot be any spaces is because simply the database will not create the table if there are any spaces in our headers. There were one, and it was the positive cases. To correct this, I simply added an underscore. I also renamed our files to use my Regis ID at the beginning to make sure there were no issues when trying to locate the file. After this, our import csv.py was ran. When looking at this code right here, you can see that it actually did go through, get the two CSV files, and create the tables as needed. After that, we had to create our query. After this, we ended up having to connect to Tableau. But before going to Tableau, I just want to make sure that everyone's aware and can see that our two tables are right here, which were the names of our CSV files in previous slides. Once we connected to Tableau, we had to make sure that the connection was first okay and secure. And since we are using an SQL query, we had to use this new custom SQL command to upload our SQL statement. After that, the report had to be made. When looking at this report, we can see that our regression model right here to the left side doesn't show a very good fit. The line is far away from the data points and simply does not look very well. When looking at this chart, though, it does kind of show a story that the rainfall is affecting it, and when low rainfall is occurring, we do have higher confirmed cases. I also included general statistics, but the part that I want to make sure that I included when doing this kind of analysis was a correlation result and R squared result. When looking at these, we can see that there really wasn't any correlation between the two data sets, and our R-squared value is so low that it just does not show any real kind of confidence in our model or correlation. Even when looking at the model itself here on the right side, we can see our equation, our R-squared value, and our p-value. Looking at this, we can see that there really was no correlation between our data sets. Overall, when looking at this project, we can see that there was a success in creating our tools and database. The tools were working as expected. The import function.py uploaded and created our tables as needed. Our import CSV simply grabbed the CSV files we needed and ran our functions. And our copy command by Postgre worked as expected when importing our dataset to its unique table. Tableau also worked at creating and connecting. It created our model and helped us work on our analysis to get the answer we were looking for. Possible projects I think would be good after this one. I was working on connecting this database and code to the Regis server. When doing so, I did run into issues. I would like to actually work on this for our data science 2. The project I would like to work on is this add to the Regis service and add an API. The API would simply create a way for users to upload any CSV file to the directory for our import CSV code to run. And then I would like to add data governance. The data governance would be needed because of the fact that anyone can upload these files, and there needs to be a way to make sure that there is some kind of control and that we're not just randomly uploading data sets and letting them sit there without being used. Last, I would like to update the import function.py to use any kind of data format. Here are my references. The biggest one I probably used was the python.org site in order to obtain the best libraries used or needed for this project. Thank you for listening.